So welcome to Java Development Tools webinar from JPassion.com. So these are the set of topics that we are covering in this course. And today we are going to cover JIT. Okay. All right, so let's move on to the presentation. So these are basically the basic concepts of JIT. And these are the set of topics that we are going to cover. So let's move on to what is and why JIT. So JIT is a distributed source control, division control system with an emphasis on speed, and is designed for maintaining a very large distributed development environment. In fact, the set of open source projects out there, such as Linux, in fact that Linux kernel is in fact the starting project where the JIT was in fact born, and Perl, Eclipse, Ruby on Rails, and Android, and PostgreSQL. So these are very popular open source projects that are using JIT. So you can see JIT is one of the most popular source control systems. Now, one very important aspect of JIT is that every JIT working directory is a full-fledged repository with complete information, complete data. So complete history and full version tracking capabilities. What it means is that it doesn't have to depend on another server on the network. Okay, and we'll actually emphasize this aspect a couple more times. I want you to just remember this. Every JIT working directory contains complete data. JIT is designed to have a strong support for non-linear development. What it means is that a lot of developers working on a project can perform rapid branching and merging. And core assumption in JIT is that a change will be merged more often than is written, meaning a lot of developers are going to actually merge and change, and that's pretty much the major activities on software development. Distributed environment. So as I said before, JIT gives every developer local copy of the entire development history. So this is the same aspect I mentioned a few slides ago, that your working directory contains complete data, including the history and changes and everything. And so these are in fact the other source control systems that actually take the same approach, especially Mercurial. So Mercurial is also another very popular source control management system, and just like a JIT, it contains, every working directory contains a complete data. And you can actually get this state, the repository from different developer and different the branches, and so it's very common that these changes are imported as additional development branches, can be merged in the same way as a locally developed branch. So enhancing distributed development environment. Alright, so compatibility with existing systems and protocols. So repositories can be published, JIT repositories can be published using HTTP, FTP, or rsync, or JIT protocol, and it could be used over plain socket or SSH. And JIT also has a CVS server emulation, which enables the use of existing the CVS clients and the CVS ID plugins to access JIT repositories. So you can actually have smooth migration if you're using CVS. If you happen to have a subversion repositories, then you can actually use it using JIT SVN. Let's talk about the JIT architecture. So this is the slide that shows Subversion and Friends. So these are the ones that are not using the approach of JIT, in which here the data is stored as a change. Okay, so we're going to actually compare this versus this. So this is how JIT works. again, Mercurial works in the same way. So let's go back to this is subversion and friends, meaning these are the schemes that are different from the way JIT works. So in this case, every version just maintains a delta. Okay, so the version 1 contains the complete data. However, version 2 just maintains the deltas. So it doesn't contain complete snapshot of the files. On the other hand, JIT, every version has a complete snapshot of the file system and then the changes. So in this case, version 2 has a complete data, and then it has this B, which contains a change. So this is a very significant change. It's a very significant difference from a subversion. So stored data is like a snapshot of the mini file system. So this version 2 reflects complete file system plus changes. Version 3 again reflects the complete file system of all the files and then changes. Okay, so that is a very significant difference I'd like to emphasize. So basically every time you commit and save the state of your project in JIT, it basically takes a picture of your file system, like a mini file system snapshot, and stores, and then the version is basically pointing to that snapshot. Okay, so this is another very important aspect of JIT. Every operation, nearly every operation, is local in JIT because your working directory contains pretty much complete data. Okay, so most operations in JIT only need local files and resources to operate. Okay, meaning it doesn't have to go to the network in order to perform most of its functions. Okay. The reason is because you have entire history of project right there in your local disk. Okay, so most operations also seem to be instantaneous because it's actually working against files in your local file system instead of actually getting the files from the net. And you can also work pretty much offline most of the time because again you have everything in your local file system. Okay, so this means that there is very little you cannot do even if you are offline, meaning you can do pretty much everything offline. However, in JIT style source control systems such as a Subversion and CVS, whenever you edit files, you cannot commit because you do not have a network at that point. Okay? In that case, the database is offline. You cannot actually commit a change. So question, if JIT keeps a copy of every file in every version, then it will take a lot of space. Is that a drawback? You can think of it as a drawback. By the way, the files are compressed, okay? But again, this is actually the difference between the speed versus the disk space. I mean, disk space is a lot cheaper than bandwidth. Okay, so it's actually an approach that JIT and Mercurial take. Okay, all right. JIT has integrity. Everything in JIT is checksummed before it is stored, and is then referred to it by the checksum. And that means it's impossible to change the contents of any file or directory without JIT knowing about it. And so basically what it means is that it has a very strong safeguard against accidental or malicious corruption. It's very difficult for someone to corrupt your working directory. Okay? And that integrity is actually built into JIT at the lowest level. So it's very difficult. I mean, you can be reasonably assured your JIT working directory is always in the sound solid state, meaning it's not corrupted. Okay, so JIT generally only adds data. So when you do actions on JIT, nearly all of them only add data to the JIT database, meaning everything is undoable and everything is kept, so you don't lose anything. With those two, I mean, you can be reasonably assured that you can do a lot of experimentation without actually causing any problem. Okay, so this is again to safeguard built in so that you can do a lot of things without being fearful of something is not going to actually work. Okay, so let's move on to a bit more concrete, usage of how to use a little bit concrete, the concrete information in terms of how to use JIT. So JIT has three main states for your files, meaning each of your files is going to be in one of these three states: modified, staged, or committed. So modified means is that you have changed the file but have not committed it to your database yet. Okay, so once you actually clone it, in fact, this is So once you clone your JIT from your JIT server, and then if you modified it, it becomes modified state. And then before you commit, you have to actually change it to staged. Okay, so we'll talk about the stage in a bit more detail. So once you actually perform, for example, JIT add, then it becomes a staged state. What it means is that it is ready to be committed, and then once you commit, it will be committed state. Okay, so once you actually clone your JIT repository, all those files are in fact committed state, and then if you modify, it becomes a modified state. And then if you actually add to the stage area, it becomes a stage state. And then once you commit, it becomes again committed state. So these are basically examples. If a particular version of the file was changed since it was checked out, okay, once it's checked out, it's a committed state, but you modify it, meaning you change, it becomes a modified state. Now, if it is modified, if it has been modified and then added to the staging area using JIT add, then it is in staged state. Okay, and then once you commit, it becomes a committed state. Okay, so three different states for each of your files. Okay, so there are, let's say three main sections of JIT project. JIT directory. This is a repository. This is where the metadata information of your the metadata and object database of your project is maintained. Okay, so this is where all your the project, the files, everything will be actually maintained. Okay, so when you clone a particular JIT project, is going to create this repository in the form of .git file, and we'll like to take a look at that in a few minutes. And the working directory is a single checkout of one version of the project, and these files are put out of the compressed database in the JIT directory. So JIT directory maintains the compressed database, which is basically all the historical data of your project. Okay? So you got a working directory where you can make changes. And then there is also what is called the staging area. It's basically a file. It's a file, and it's called sometimes an index file. And it is actually contained in your JIT repository that stores information about what will go into next summit, meaning the set of files that have been modified and added. Okay? So this is it's called the staging area. Okay, so this is basically state changes, actually reflecting state change of your file. Okay, so let's say you have cloned JIT project from somewhere. Okay, so it creates a repository. Okay, and so once you have the working directory, so once you check out the project, it actually has a working directory and JIT repository. And then by adding those files to the staging area, you're going to actually use what is called the JIT add. It becomes staged state, so it is listed in the staging area, and then from the staging area you can commit. Okay, so you cannot actually go from the modified files to the committed state directly. You have to stage it first. Okay, and we'll talk about why you want to have this middle staging area in between, okay, in a few minutes. So question, can a modified file get committed before being staged before that? No, the answer is no. You have to go to the staging area first, and we'll again talk about why the concept of staging area is actually in JIT. Alright, so moving forward, JIT workflow. So this is again kind of, give you a sense of how things work. So in your working directory, okay, you're going to actually make changes, okay, and then you're going to actually stage the files, okay. So basically this index file, this is staging area. So you're going to actually add it, meaning you're going to actually use the JIT add to add those files to the staging area. And basically staging area is a list of the files that you want to commit, okay. These are the set of files that you added or modified and then you want to commit. So you have to go through this staging area, okay, and then you can commit. And then we are going to actually mostly focus on local repository for now. Later on we are going to talk about remote repository. This is where you need the collaboration with other developers, but for now, basically you have a local repository, and then from the local repository you have a working directory, and you make changes and you make changes to existing files or you add new files, and then if you want to commit those newly added files or change files, then you're going to add them to this staging area called the index, and then you can commit, okay. Alright, so how to get started? So basically you have to download the JIT for command line operations. You can actually work with JIT at the command line, or you can use JIT plugin in your IDE. So the eJIT is for Eclipse plugin, okay, which you are going to actually use for the hands-on lab. The first time you're going to use JIT, you have to set some configuration. For example, you have to give your identity. So these are the identity that will be used whenever you commit a change, for example. So you're going to use this command line command, JIT config -- global username, and then you specify your name, okay. And you also specify your email address. Again, JIT config -- global user.email, then you give your email address. You also specify the editor of your choice. So whenever JIT needs to actually let you edit some file, it lets you choose to use your favorite editor. So in this case, I'm actually specifying Emacs as my default editor. So when you actually check in, and meaning when you actually commit a change, you want to actually add some the statement to that commit, right? At that point, JIT will invoke this editor of your choice so that you can add some statement for that particular commit. And you can also specify your diff tool. So here, config global merge.tool, and then in this case we are using vim diff. Okay. And these are the things you can set. I mean, this configuration also could be set from the IDE if you're using, for example, eJIT plugin. And this information will be saved in your home directory. So once you set up at the command line, you don't have to set it in next time if you're using, for example, an IDE. Or if you set it from the IDE, again, you don't have to set it at the command line, okay? Because information that is configured will be set in your home directory. Okay, now you can check your settings. For example, you can say JIT config -- list, and then it will give you the list of configuration you set. So let me actually try on my system. So I'm going to say JIT config list. So my Gmail address, username, and things like that. Okay, moving forward. Getting JIT repository. So there are two different ways that you can get a JIT repository. Okay? So basically you are checking out a project. That's what it means by getting a JIT repository. So you're building your own repository. So you can so there are two different approaches, well, two different ways, and you're going to use both. Okay, in many cases, not at the same time. So suppose if you have existing project and then you want to place that project into JIT. In that case, you're going to take this approach, taking an existing project and then import it into JIT, meaning you are going to place that into your JIT system. Or you could clone an existing JIT repository from another server. So this is what you're going to use for many of the open source projects. So if you have, if you want to participate in open source project, basically that open source, if that open source project is already in JIT, and then you can just clone it. Okay, so let's take a look at each of this in a bit more detail. Alright, so this is the first approach, meaning you are going to place existing project into JIT. Okay, so you go to your project directory, and then the command that you're going to use is JUnit. Okay, once you do this, it will create JIT repository called .jit in your project. Okay, so this is the repository that contains everything. Okay, so it will actually contain like a compressed version of your snapshot file system. Okay, and then you have a working directory as well, so you can make changes. So you could add some more files. Okay, so these are, once you actually add files or modify existing files, okay, those needs to be changed to staged state, meaning you have to put them into staging area. So that is this command. So when you say git add and dot, that means I'm actually putting everything on the current directory into staging area so that I can commit. Okay, and then I can commit. I can say git commit, and this is the message that I like to associate with that particular commit. Okay. Okay, so that is when you are placing your existing project into JIT. Now, the second scheme is, suppose you have already a project that is in JIT. Now you want to clone it. Okay, this is how you do it. You are going to use clone command. So you say JIT clone and the location, and then location of that JIT project. So if that JIT project is in GitHub, okay, we are going to say git clone and then location of that project. Okay. Now in this case, if you say git.git, basically it will create. So this is grid is the name of the project. So it will create project called the grid, and then underneath it will generate -git directory. Okay. So let me just try this. I'm going to just say my project. Okay. And I'm going to just say this. So you can see it's receiving all, it's actually getting all those files. Okay. So I should have a grid. So if I say now here, I should have a grid, and I go grid here, and then you can see I have I should have -git directory. Or maybe this is the one. Okay. Now, if I want to have the project name as the mygrid, then you can actually use another parameter called like this. Okay. Okay, so I should have now not my grid. Oh, I actually created not in this grid directory. So I should actually go right here. So let me try create here rather than underneath it. Okay, so now I should have a my grid. So if I go to my grid, now everything is actually downloaded. Okay. Okay, so that is and JIT supports several transport protocols like a JIT. Typically that's read-only operation, but it's very fast, and that's basically what I used here. Okay, you can use SSH. This is preferred for writing. And you can also use HTTPS, and it's slow, but it's not blocked. Okay, so if you are working within the firewall, this might be your only choice, because these two might be actually blocked by the firewall. Okay, so this is basically what I showed you. You can say the git clone and git love hello git, and then you can go to hello git and you can edit files, and then that becomes a modified state, and then you can add those files into staging area. Then you can actually commit it. Okay, so something I just showed you, something that actually showed the basic set of steps that you're gonna follow. Okay, so recording changes to the repository. So, this is again giving you a sense of the state of the file. So each file in your working directory can be in one of the two states, tracked or untracked. So when we say, those three states, we are talking about mostly for the files that are being tracked. Okay, so modified, staged, and committed. Those are for tracked files. There are also files that you do not want to track. Those are untracked files. Okay, all right. So the untracked files are the ones that you do not want to check. For example, like a temporary files, or actually files that are being generated. The log files and things like that. Those files you do not want to place them into your JIT repository, right? Okay. So again, the modified and unmodified and staged and committed, those are for the tracked files. Now, when you first clone a repository, all your files will be tracked and unmodified state, because you just checked them out and haven't edited anything. Once you edited one of those files, it becomes a modified state. And then once you add it to staged area by using git add, it becomes a staged state, and then you can commit it after that. So these are basically reflecting the untracked state. So these are what we have seen before, but we added untracked state. So untracked state is that basically you can add a file. Suppose you clone a project, and if you add a new file, okay, at that point it becomes unmodified, and then you can edit the file. It becomes a modified state. And then you can stage the file to the stage area, and then once from the stage area you can commit it, and once it becomes committed, it becomes a modified state. And if you remove the file, then it becomes untracked state. Okay, moving forward. The way that you can find out the status of your files is using git status. So if you say git status, and it will tell you there is something to be committed or something nothing to be committed. Okay? So if you clone your project for the first time and then say git status, it will say nothing to commit because there has been nothing to be in the staging area. Okay? So basically, once you run git status command right after cloning, you should see something like above. Okay? You have a clean working directory. In other words, there are no tracked or modified files. JIT also doesn't see any untracked files. By the way, if JIT actually track any files that has been added, meaning untracked files, and they would be listed here as well. And finally, the command tells which branch you're working on. So as a default, it's going to be master. Okay, so in this case, we don't have any other branch, so a single branch called the master. Checking the status of your file. Suppose I added a new file, okay, called the readme, and then if I say git status, it will tell me that this readme file. So this is untracked files. Is telling me. Okay, so it says, oh, you just added a new file and it's untracked. Okay, so you can actually find out the JIT will actually tell you untracked files. Now, if you add that file by using git add, then you're actually making it as a staged state. Okay, so now if you say git status, it will tell you that changes to be committed, meaning this is the file that has been in the stage area but has not been committed. So it will tell you this new readme file is changes to be committed state. Okay, and suppose if you actually modify the files, let's say change the file that has been already tracked. So in this case, there has been, let's say, benchmarks.rb file, and then again it will tell me that these files has been modified, but it's changed but not updated, meaning it has not been changed to staged yet. So in order to add it to stage area, you're gonna actually use again git add file. Okay. All right, moving forward. Ignoring files through .gitignore file. So there are many files, many file types that you do not want to keep track. You do not want to track. For example, like a log file or temp directory or PID directory. See, these there is no value keeping track of these files in your source control system. So in that case, what you can do is that you can have this gitignore file. Inside the gitignore file, you can specify the type of the files that you do not want to keep track of. So in this case, star.ona, that means that I do not want to put any files that ends with either O and A into this git. And this one is also saying that I do not want to keep track of any files that ends with this tilde. Okay. These are the examples of gitignore file. So the .a, I don't want to keep track of any file that ends with .a. However, this is if you have exclamation mark, but I like to keep track of this particular file. So for most of the .a file, I don't want to actually keep track of, but for this file, I want to keep track of it. So in this case, exclamation mark live.a. When you say /to-do, that means ignore the root to-do file, but not subdirectory of this to-do directory. Okay. In this case, a build and the slash, that means ignore all files under this directory. This one, doc/star.txt file, meaning ignore any files that ends with a text at this particular directory, but not in subdirectories. Okay, so you have a reasonably good, flexibility in terms of what files you want to, ignore. Okay, so viewing your changed and unstaged files. Sometimes you want to see what is the change I made before I want to actually, for example, like a commit. Okay, so you can say you can say git diff. Okay, and then it will let you see the changes. So here it will actually tell me these are the new method I have in fact added. Okay. Viewing your staged and unstaged files. So here, to see what you've staged, that will go into next commit. Then you can say git diff and -- staged. Okay, and it will give you all the files. In this case, we have a single file. Okay, but it will give you all the files that are going to get staged next time you perform commit. Committing your changes, as you have seen in example, will say git commit. Okay, and then it will commit all the changes that you have made, and they are actually on staged state, meaning they are in staging area. Okay, and if you say git commit, it will prompt you to enter some statement that is associated with the comment, actually associated with that particular commit. Okay. If you use -m, that means this is the message, this is the comment I like to associate with a particular commit. Okay. Okay, skipping the staging area. So this was the question that was asked a few minutes ago. Is there any way that I can actually skipping the staging command? Okay, you can skip. Logically you cannot skip the staging. Okay, but in terms of command, what you can do is that you can use -a and -m. So what it means is that I'm actually staging and also doing the commit at the same time. Okay, so that is actually shorthand for performing those two in a single command. So here, basically, what I'm doing is I'm doing a git add, and then I'm also git command. Okay, so I'm actually moving the file into the staging area, and then I'm committing at the same time. Okay, so let me see if there are some questions. Okay, so let me just move on and actually get to the questions. Viewing commit history, so you can actually suppose if you clone the existing JIT project, and then you can just say JIT log, and then it will give you all the things that that have happened on that particular JIT project. Okay. So you can see once you clone a particular project, you can see who has committed and what changes. One of the more helpful option is -p, which shows the diff introduced in each commit. So you can, in addition, here it's gonna just tell you who has committed and what change has been committed. But here you can also see the changes that have been committed in each commit. Okay, and you can also specify -2 or -3, which limits the output to only the last 2 entries or 3 entries. Okay, so before we move on to remote, I'm going to actually take a look at the questions, and then we'll actually do the hands-on lab first. Okay. So let me address the question again from the Yavar. Can a modified file can get committed before being staged before that? As I said before, the answer is no, but you can use single shorthand command -a and -m to do the same, to do both at the same time. Okay, but logically you cannot commit before having it in staged. Okay. The reason, yes, I think I actually didn't. I thought I was actually. I had a slide that actually showed you why we need the staging area. The reason is this: there are files that you do not want to be, committed automatically. For example, like temporary files that are being created, or binary files that are created after compilation and things like that. So you don't want the JIT to automatically commit all those unnecessary files. Okay, so you can actually use the JIT ignore, and you do not also actually have those files to automatically committed. So that's the reason JIT actually requires you to specify the set of files that you actually want to make sure that you want to actually commit. Meaning you want to actually keep track of. You want to track. Okay, so that's the reason that is a staging concept. If you change a file multiple times and staging and finally commit just once, will JIT store the history of all these intermediate changes? No, it will have one staging, and then staging is basically a set of list of the files that will be committed that are actually candidate for the commit. Okay. So the if you actually add multiple times, the last one, it's basically that multiple times put add is the same thing as just once put add. Is there a limit or number of days where you can keep the files in the staging area? No. Does it have expiration? Also, can you modify the files again in the staging area? Yes. Yes, you can actually once you have in the staging area, you can make a change, and again you add one more time. Okay. Let's see. Do you know if there is any possible integration with a clear case? I don't know the answer. A clear case is another yeah, I don't think so. Yeah, I don't think there is actually a plugin or something like that for clear case. Okay. The only plugin that I actually am aware of is the SVN. How can I reverse the committed version? You cannot reverse it. You can make a change back, and then you can actually commit it again. Okay, so that those things will be maintained. Okay. So all the historical changes will be maintained, and so there is no concept of reversing it. There is of course you can actually change it back to is the original whatever your code. Okay, but there is no reversal, and that's by design, of course. Are you going to cover merge conflicts in JIT? Actually, that is actually no remote, but I don't have any detailed slides for that. But merge is actually merge, so it's not that much a big deal. when I commit a change offline, what happened to the changes when I'm online? When I commit a change offline, what happens to the changes when I'm online? Oh, I see. So, you can make all the changes offline, and so basically what you are making a change is your local repository. Now, when you are going to actually push the changes to, let's say, remote repository, that's the time that, you're going to actually use these remote things, which you're going to talk about in a second, okay? I can't get where there is a staging status. I'm not sure. Hironi, Anis, yeah, can you actually ask the question again? There are several typos. I cannot really read it. Eclipse also maintains history, although it is not central repository. Yeah, but the thing is that whole idea of the source control system is collaboration. We haven't really talked about the collaboration aspect of the JIT yet, but the main reason you want to use the source control system is the collaboration, meaning there are many developers working on the same project, meaning same file, and you won't let them to work at the same time without actually having too much interference, right? That is what the source control management system is all about. Okay, so JIT is actually more than just maintaining a historical information, as you actually saying. Okay, so most of the time the value of the source control system is for collaboration. I can't get why there is the staged. When you say STATUT, what do you mean by that? Hironi? Staged. Yeah, so again, retype the question. Okay, so let's move on to the hands-on lab. Okay. Okay, so here the first exercise is installation of the JIT, the standalone package, and also installation of eJIT in Eclipse, the IDE. So you go to this website, and then you're going to download a JIT of your particular platform. Okay, all right, and then you are going to basically you just unzip the file, and then the bin directory you want to actually put in your path, okay, so that you can invoke a JIT command, okay, just like I did here. So if I say JIT, then you should actually see oops, not this one. Let's say here JIT, and you should actually see this command. And if you want to work mostly on an IDE, then you want to install the plugin. So in this case, we are installing eJIT plugin to Eclipse IDE. So you go to Eclipse Marketplace, and then you just type JIT, and then click this search icon. Then you're going to see this eJIT, and then you're going to just install it. Okay, and you're going to install both eJIT and JJIT. Okay, exercise 1 is first time setup. So here we are actually using command line tool, but you can do this one from eJIT as well. So I'm setting global username to John Doe, and also setting the global email address. Okay, and you can set it from IDE. So you say Windows and Preference, and then you expand Teams, and then you are going to expand JIT, and then if you click Configuration, here you can set your again editor name and email and things like that. Okay. All right. So exercise 2 is place existing project under JIT. So here we are going to actually work on the pet clinic, whatever project of your choice. So here we're going to choose a pet clinic project that we worked on before. Okay. So you're going to actually right click, you import that project first of all, and this one is not in JIT yet, so you say right click and then select team, and then you select share project. Okay, and then here you're going to select JIT. Okay, and then next, and then you select the project, and this is where .jit will be created. Okay. So so you can just select this one and unclick this one and this one, and then basically it will create .jit directory in the Pet Clinic SDK. Okay, so once you've done that, you're gonna see this repository. So for this project, the repository is represented by .jit directory. Okay. And then you can see repository in show in repository. So you say the right click team and show in repositories. Then it will give you this project under this repository. Again, this is your local repository, right? Okay, and this is your working directory. Okay. So here, next step is we are gonna create .jit ignore file. So here you're gonna say you just select directory that you want to add to the .jit ignore. So you just say I want to actually add target directory on the JIT ignore, because I don't want to actually put target into the track JIT. So basically right click it and team and ignore, then it will be added into .jit ignore file. Okay, so you can see if you just see the contents of type.jit ignore, you can see there's a target is included. Okay. All right, and these are the common set of patterns and that typical JIT project has. So you don't want to actually track the project class path and settings. For IntelliJ, these data files, and for the Maven, again the target. Okay, so you can certainly add whatever the file types that you do not want to keep track of in JIT. And now we are ready to place a file into JIT. So here basically I'm gonna actually every file that I have in my working directory into this into staging area. Okay, so I can actually use JIT add and dot on the project directory, or I can right click it and then team and add. Okay, so same thing. Okay, or you can select a particular directory and add. Okay, or file. So here I'm actually putting everything in this project into add. Okay, now if you say JIT status, it will tell you these are the files that have been moved into staging state. Okay, so these are all the files, pretty much every file, because I have done the JIT add at the root directory of that project. Okay, and then I'm going to commit. Again, here I say the project and the team and commit, and then it's gonna ask you, what is the message that you want to add for that particular commit. So I say this is the initial commit. Okay, and then commit. Then once you did the commit, then JIT status, then you can see there is nothing to commit because everything has been committed, meaning every file at this point is modified state. I'm sorry, the unmodified state. Okay, because we just commit them all. And make and commit a change. So here we are going to make a change. So here I'm going to change one of the files. So I go to owner validator.java file, and then we make a change. Okay, and as soon as you make a change and save the change, you can see there is in fact a flag indicating this directory contains a file that has been in what state? Modified state. So this owner validate is a modified state. Okay, so now when you say JIT status, it will tell you it is a modified state. Okay, now in order to commit it, you have to add it, meaning you want to actually change the staged area. So that's the reason it say use JIT add in this file to update so that it will be in the staged state. Okay, now we're gonna do add. So you're gonna actually change it to staged state. So you're gonna use JIT add. So right click that file and team and JIT add. Now you can see it is has a different flag. So what it means is that now it is the staged state. Okay, Now, if I commit a change, then I'm going to actually say the team and commit. Okay, and then I will actually make a first change and commit. Now, if you say git status, again, nothing to commit, meaning everything is again unmodified state. Now, if you want to see the log, history, then you go to the project and you can see git log at the command line. You can certainly do this one at the IDE, which is what this is all about. So here you can see there was the initial commit change, and then I made a change for this particular file. Okay. All right. So here again you can see show history, and it should actually show the same information. Exercise 3 is cloning a JIT project. So exercise 2 is you are putting existing project into JIT, and exercise 3 is now you are cloning existing JIT project. Typically, when you are cloning existing open source JIT project. Okay. So here we are going to actually try the Spring MVC showcase the project. Okay. So here we're going to actually use this one. Okay. And basically you're going to say JIT clone and JIT, okay, and then so I'm going to just try this. Looks like if I have my own, okay, so this is already there, so I'm going to just change this guy. Okay, now I'm going to, so we don't have that. So now we are going to JIT clone it. Okay. Now it's cloning that project. Question from Yavor. Does JIT remember operations such as file rename, relocation to other directory? Absolutely, yeah. So now we have the Spring MVC showcase, and we have this JIT store, and so this is now in the we just did this. I'm actually puzzled why it doesn't have a JIT. Oh, okay. So it does have it. It just doesn't show in my dir. Okay. So if I say minus the JIT. Yeah, so it is there, okay? It just doesn't, if I say dir, it doesn't show it, okay? So if I say dir minus L, I'm not sure. Okay, what is the, I forgot the command of the Windows of dir that actually shows the minus, the dot things, okay? Or that is actually properties for the, so anyway, I'm actually using the ls, and you can see there is a minus JIT directory, okay? Let's see. Directory A. Okay, so that is the command. So you can use directory A like this, and then you can see that JIT directory is created. Okay. All right. So that is that. Now I have 5 minutes, so let me actually finish up the working with remote. So far, what I've shown you is working on your local, the JIT repository. Again, the real value of source control management system typically is the collaboration. So this is where you're gonna work with other developers. So to be able to collaborate on any JIT project, you need to know how to manage your remote repositories, because remote repository is the one that actually maintaining changes from multiple developers. So remote repositories are the versions of your project that are hosted on the net, and you have several of them, each of which is generally read-only or read-write for you if you have write access. So this is in fact the what this remote repository is all about: collaboration with others. Okay? So these are the things you can do with remote repositories. So you can see remotes, and you can add remote repositories. You can fetch and pull, and you can remove, and you can also manage various remote branches and defining them as being tracked. Okay, so let's talk about each of these in a bit more detail. So you can say git remote command. It will actually give you all the remote repositories. Okay, so suppose I clone this guy, and then if I say git remote, it will actually give me one single remote repository. Okay, so you can also have a verbose mode, meaning I have a single remote repository I'm dealing with. Okay, all right. So for this particular project, okay, so here, suppose I clone a particular project called the tickjit, then I go to that project, and then I can see there is only a single remote server for that particular project, remote repository server. Now, if you want to add another remote repository server, then you're going to use add command. So git remote add, this. Okay, so here, this is a case that your project involve multiple, for example, open source project. In that case, you will actually add another remote server. So now if we say git remote -v, then it will say, it will give you 2 remote repository servers that you're actually dealing with. Okay, fetch. So fetch is when you actually, fetching changes made by someone else. Okay, so git fetch goes out and goes out to that remote project and pulls down all the data from that remote project that you don't have yet, meaning whatever changes that are made by someone else. Okay, so after you do this, you should have references to all the branches from that remote, which you can now merge or inspect anytime. So this is where you can actually merge. Once you do the fetching, then you can do the merge. Okay, so this is the command. So git fetch and pv, that is a remote server. Okay, now if you clone a repository, the command automatically adds that remote repository under the name of origin. So when you actually see origin, that is a default. Okay, so git fetch origin is the same thing as git fetch. But if you have a different remote server, then you have to specify git fetch and remote server, remote repository. It is important to note that fetch commands pulls the data to your local repository. Now, it doesn't automatically merge it with your work or modify what you've been working on. I think that was one of the questions that was asked. Okay, so you have to merge it at that point. Okay, so you have the files, but you have not merged with your changes. Okay. Now, if you want to have a branch set up to track a remote branch, you can just use a git pull, and it will automatically fetch them and merge a remote branch in your current branch. So git pull is actually, they're doing the merging as well. Okay, and so it's basically, the shorthand for fetch and merge. Now, if you make a change, and if you merge all the changes, then you can push those changes back to the remote server. Okay, so that is git push. Okay, so this is the remote repository, and then this is your branch. So if you have a multiple branch, you might actually specify different branch, but as a default, the branch you got is a master. Okay. Inspect a remote. So you can say git remote show origin, and then it will actually tell you, the remote branch merge with a git pull with on branch master tracked remote branches. It will give you all the information in terms of, how they are in fact actually merged. This is the way that you can rename a remote. It's not that much of a big deal, and remove a remote. Okay, and tagging. Tagging, tagging is actually supported pretty much all the version control systems. So it's the ability to tag specific points in history as being important. Generally, people use this functionality to mark release point. Okay, so list your tags. You can say git tag, and you can also search for tags. Okay, like this. And this is how you can actually tag the creator tag. So git tag, and you're adding v1.4. And then when you actually so that is actually lightweight and annotated tagging. Lightweight tagging is very much like a branch, doesn't change, it's just a point to specific commit. Annotate change, so this is typically what you're going to use. Stored as a full object, so this is annotated tagging. Alright, so that is the end of the presentation, and it's 10:30, so I'm going to just